Okay. Good morning and assalamu alaikum to one and all. Before we continue, please do you guys confirm that you can hear me? Hello. Okay, cool. Okay, guys, welcome to the inaugural grade 8 lesson for mathematics. My name is Abdullah Ali. I'll be your tutor, hopefully for the rest of the year for your grade 8 mathematics tuition, right? It's good to have you guys along the journey, and I really hope that these classes can benefit you guys and that we can improve your marks. Okay, so just one thing quickly. I see that one of the attendees has their hand raised. If you have a specific question, what you can do in the meantime is there is a Q&A option. So if it's maybe something you don't want to put in the chat, there is a Q&A option which you can use to ask your question, and then I can either answer you there or live, like in person. Okay, cool. So right in early in the morning, let's get started, right? So today we're going to be starting with whole numbers. Okay, so we're going to be doing some basics, right? Some understanding of the basics. And yeah, if you have any questions, feel free to ask them via the Q&A, via the chat, and I'll try my best to get to as many as possible. Okay. So firstly, we're going to start off with numbers, right? The first thing we're going to talk about are our real numbers and non-real numbers. So real numbers can be defined. It can be found there, and non-real numbers can be found here. So the first thing we're going to discuss is the screen updating. Just confirm with me if the screen is updating. I feel like it's not updating. Okay, yeah, sorry. Also, first lesson. So please forgive any jitters or any technical issues. I'm going to try and reshare my screen and we're going to go again. Okay. Cool. Let's hope that the screen updates with us now. Okay, perfect. So yes, we were discussing real numbers and non-real numbers. So the first thing we're going to start off defining are our non-real numbers. Okay, so we can see the definition here. We say that non-real numbers are defined as imaginary numbers or numbers that are not real. Okay, so basically a non-real number is any number that has a negative inside of a surd. Okay, so a surd is a square root. Okay, and an example can be seen here where we have negative 25 inside of our surd, negative 1/16 inside of our surd. So any negative that where the overall number inside of the surd is negative, that is going to create a non-real number. Okay, what is a real number? Basically everything else. So the simple way to understand it is non-real number, negative inside of a surd, and real number, everything else. Okay, then we're going to further break down our real numbers. We have two types of real numbers, the first of which is rational numbers, second of which is irrational numbers. Okay, so let's look at the definition of a rational number. A rational number defines as it's a number that can be written as a over b, provided that b is not equal to 0. So basically it is a number that can be written as a fraction. Okay, and of course we'll go through it in a bit, but in a fraction we cannot have the denominator equal to 0 because it will be undefined. Okay, so a rational number in simple terms is any number that we know the complete value of. Okay, so for example, if I have a number 2, if I have a number, let's say, where's my calculator? Let's just say 3/5. I have the number 20,5. Okay, so this might not make exact sense just yet. Let's maybe go through what an irrational number is, and then a rational number will make more sense. So an irrational number is a non-recurring or non-terminating decimal. So basically an irrational number is a number that has no end. Okay, so if we look at pi, for example, or we can start off with root 5. If you take root 5 and you input it in your calculator and you say equal to, you are going to get a decimal. Root 5 is going to give you 2,236067977 and so on. So this number goes on till forever. Okay, the reason it stops at 7 in your calculator is because that's all the memory that your calculator has. But in fact, this number will go on till forever. It has infinite amount of numbers. So we actually don't know the end of this number. Now, that type of number is what we would refer to as an irrational number, okay, where we don't know the end. So too is the same with pi. So if I input pi in my calculator, pi we generally learn as 3,14. But if you have to put in your calculator, you'll get the full value that is 3,141592 and so on. It goes on till forever. So these are irrational numbers, numbers that do not have an end. We do not know the entire value. However, opposite to that, again, are our rational numbers, numbers that we do basically know the entire value of, and all of those numbers can indeed be written as a fraction. They can be expressed as a fraction, whereas irrational numbers cannot be expressed as a fraction. Well, they can, but they do not give us rational values. Okay, so when we look at numbers like these, for example, if I convert this number to a decimal, I get 0,6. So this does not have an infinite amount of decimals. It just has 1. We know its entire value. So too does the number 2, the number 20,5, and many other values. Okay, so that's the difference. That's two distinguishable numbers within real numbers, rational numbers and irrational numbers. Now, within real numbers, we have a second type of numbers that are known as integers. We have a third type, whole numbers, and a fourth type, natural numbers. So let's start from the bottom. Natural numbers are the natural way that we count. Okay, so when you're playing hide and seek, nobody starts counting from 0, 1, 2, 3. When you count, naturally, you say 1, 2, 3, 4, 5. Okay, so the natural way we count. Whole numbers, okay, are exactly like the natural numbers, including 0, however. Okay, and whole numbers do not contain decimals. So something such as 3,5 is not a whole number. Okay, so just the natural numbers, including 0. Then we have integers. Okay, integers are like natural and whole numbers where we go 0, 1, 2, 3 and till forever. However, integers include our negative numbers as well. Okay, so those are important to distinguish. Within real numbers, we have rational, irrational. Within under rational, we have integers, whole numbers, natural numbers. Then we have non-real numbers, which is basically a negative within a third. Okay, let's talk about some important terms that you need to understand. The first of which is a factor. Okay, a factor is a number that can be divided into another number with no remainder. Example, the factors of 20 are 1, 2, 4, 5, 10, and 20. So again, like they said, right, a factor is a number that can go into another number an exact amount of times. So if we consider the number 20, we know that 5 can go exactly into 20 4 times. So that's why 5 is actually a factor of 20, right? So 2 is 1, 2, 3, 4, 5, 10, and 20. All of these values are factors of 20 because they can go into 20 an exact amount of times. Okay, the next term we're going to revise is a multiple. A multiple, the multiples of a number are found by multiplying the number by only natural numbers. Okay, so basically a multiple is your multiplications timetable. Okay, so let's look at the example. It says the first 5 multiples of 5. The first 5 multiples of 5 are 5, 10, 15, 20, 25. So again, according to the definition, the number is found by multiplying that specific number by all the natural numbers. So let's say, what are the multiples of 5? We would say 1 times 5, 2 times 5, 3 times 5, 4 times 5, and so on. All of these values are multiples of 5 because we're multiplying them by the natural numbers, all of them. Okay, the next term is prime numbers. A prime number is a number that has only 2 factors, 1 in itself. So we discussed what is a factor. A factor is a number that can go into another number an exact amount of times. Then we have specific numbers which are called prime numbers. These numbers only have two factors, 1 and itself. We'll go through the prime numbers in a bit, but let's consider 3. The factors of 3, meaning the numbers that can go exactly into 3, are 1 and 3. Okay, I just want to answer a question quickly. Will this stay live on YouTube? Yes, this will remain live on YouTube. Okay. Right, so those are prime numbers. Okay, we'll go through the list of prime numbers, and you should know your first few prime numbers, right? Then we just, okay, then the example is that 17 is a prime since its only two factors are 1 and 17, so 2 is 3. Okay, then we can talk about composite numbers. A composite number has more than two factors. So basically, a composite number is the opposite of a prime number. Again, a prime number only has two factors. Well, composite numbers have more than two factors. So you have prime numbers, and then you get the rest of the numbers, which are known as composite numbers. Okay, so these are some important terms that we need to note, we need to understand. Okay, let's discuss division by 0. In mathematics, we say that division by 0 is undefined. This is because there is no value for that in calculators, such as those in question 2. Okay, in previous exercise. Okay, that's fine. Next point, if you try to find 6 divided by 0 using a calculator, it will give you an error message on the screen. This also applies to 0 divided by 0, which is not equal to 1, even though 0 times 1 is 0. Okay, whatever it is, right? We just need to remember always till matric that anything divided by 0 is undefined. Okay, that's the main thing. No need to get more into that. Okay, let's move on. Let's discuss some of the properties of whole numbers. Okay, some important properties that you are required to know. Okay, the first of which is the commutative property of addition and multiplication. Okay, so in question 6, okay, obviously we don't have question 6, but basically it says you will have noticed that the order in which you add or multiply numbers does not matter. So that is the key thing. That is the key understanding of the commutative property of addition and multiplication. Again, it is the order in which you add or multiply numbers does not matter. Okay. However, importantly, this does not apply to subtraction and division. So commutative property is only for addition and multiplication. So let's look at an example. If we look at an addition example, using 12 plus 4, okay, will give you the same value as 4 plus 12. So in an addition sum, the order in which you put your numbers does not matter. So you could say 12 plus 4, you could say 4 plus 12, you're still going to get the answer of 16, irrespective of which order you put it in. Again, this is like only if we have addition in our sum. So this is known as the commutative property of addition. The order in which you add any two numbers does not matter. It is also interesting to notice that if you add any two whole numbers together, you'll always get another whole number. Okay, let's look at it for multiplication. If we say 12 times 4 or 4 times 12, it doesn't matter. The order in which we put it doesn't matter because we're going to get the same answer, which is 48. Okay, so multiplication also has the commutative property. Okay, note that subtraction and division do not have this property. So let's look at this example. 12 minus 4 is equal to 8, but 4 minus 12, that's equal to negative 8. Okay, the answers are not the same. 4. The same thing for division. 12 divided by 4 is 3. 4 divided by 12 on the other hand is 1 over 3. The answers are different. So subtraction and division do not have the commutative property. Okay, let's move on to the associative property of addition and multiplication, or the grouping property of addition and multiplication. So let's just look at the key point. The way in which you group numbers when you just add or just multiply does not matter. For example, if we have only addition, okay, we could, so remember, we will go through this in a bit, but remember the order of operations, BODMAS, right, where we always start off doing our brackets. Okay, we'll get to the rest, but it's key important to know for now that we always start off doing our brackets. So when we put our own brackets into a sum, that is important because that means, okay, you need to start with that. So in this case, where we have put the brackets has changed. Okay, so in this case, we have 5 plus 6 plus 2, but the brackets we put on 6 plus 2, so we know we're going to do that first. On the other side, we have the brackets on 5 plus 6, so we know we're going to do that first. However, because of the grouping property of addition, it doesn't matter where we have brackets or what we group. So if we do the calculation, 6 plus 2 is 8, 8 plus 5 is 13, 5 plus 6 is 11, 11 plus 2 is 13. Again, we grouped it differently. However, we got the same answer. The same can be said about this. Here we grouped 6 times 2. So 6 times 2 is 12. Let's use 6 times 2 is 12. 5 times 12 is 60. So here we get 60. 5 times 6, that is 30. 30 times 2, that is also 60. So again, associative grouping property of addition and multiplication. It does not matter what we group in brackets. We will get the same answer, provided that we only have addition or only have multiplication. Okay, the distributive property of multiplication over addition and subtraction. Okay, this property is known as the distributive property of multiplication over addition and subtraction. This means that the number outside the bracket can be multiplied by each number inside the bracket if the numbers inside the bracket are added or subtracted. You don't need to use a multiplication sign in front of the bracket, for example. Okay, so let's start off with the first sum. Okay, as you can see, we have 5 times a grouped addition. So 5 times and then in brackets 7 plus 3. So distributive law basically tells us that when we have a multiplication before a bracket, let's just say A plus B, what we need to do, in fact, is we need to take that, we can call it the coefficient of the bracket, and we need to distribute it inside the bracket, meaning take this number and multiply it to each term inside the bracket. Okay, and we keep the signs the same. So for example, in this case, what I would do is I would say 5 times A, which is actually 5A. Remember, this is a positive 5 and that's a positive A. The positives are invisible, but it's positive 5 times positive A, which gives me positive 5A. Then I say 5 times B. Again, this is positive 5 times positive B. So I get positive 5B. Okay, so that's the distributive law. So similarly, in this example, we have 5 times 7 plus 5 times 3. So that's how it can be written as. Okay, let's leave that there. 5 times 7 plus 5 times 3. Let's look at this. You don't actually have to show that multiplication that they're showing, okay? Because the bracket already indicates a multiplication, and we have the same thing. Again, if we had 5 into C plus Q, this would be 5 times C plus 5 times Q, or just 5C plus 5Q. Okay, cool. Let's talk about order of operations, BODMAS. So we have brackets, order, which represents our exponents, division, multiplication, addition, and subtraction. Right, so of course, we follow BODMAS throughout any mathematical expression or equation. All right. So firstly, we're going to do our brackets in any sum. Secondly, we do our exponents. Thirdly, we do division, multiplication, addition, and subtraction. Now, when we say left to right, what exactly does that mean? It basically means that if you're only left with division, you work from left to right. If you're only left with multiplication, you work from left to right. If you're only left with addition, same thing, and subtraction, right? So let's do a simple example. If I have 5 plus 6 plus 7 plus 2. Now I want to follow BODMAS. I have no brackets. I have no exponents. I have no division. I have no multiplication. I go straight to addition, okay? Now, in which order am I going to do this addition? Okay, you just simply go from left to right. When you only have addition, you go from left to right. When you only have subtraction, you go from left to right. And so is the same for multiplication and division. Again, we remember from the, what is it? The commutative property. Sorry, the commutative property of addition, that either way, it doesn't matter in which order we do this, we're still going to get the same answer, right? So BODMAS, when we only have addition, we just do it from left to right. Okay. Okay, cool. So before we get into anything complicated, like especially with BODMAS and maybe like some BODMAS sums, BODMAS equations, BODMAS expressions, we're going to revise basic calculations, okay? Addition, subtraction, multiplication, and long division. So starting off with addition, we're just going to revise how to do addition using our columns, okay? And how to do subtraction, multiplication, and division as well. Long division, that is. Okay, cool. So addition, what you want to do is, these are my thousands, these are my hundreds, these are my tens, these are my units. Okay, so what you want to always do is, in this case, I have an 8,769, so it's a number with the thousands, and I have 482, so the number with the highest is 100. Okay, but what you always want to do, irrespective of which numbers you're adding, how big or how small the two numbers are, how different they are, you always want to line up your units under your units. You always want to line up your tens under your tens, your hundreds under your hundreds, and your thousands under your thousands. Of course, 482 doesn't have any thousands, so it just remains blank. So when you do the calculation, all you're going to do is you simply are going to add. So you're going to say 9 plus 2. So 9 plus 2 is 11. So what you do is you write down your units value and you take over your tens. Okay, because you can't write two values there. You're only writing one under each one. Okay. So now, instead of having 6, you have 6 plus 1. You add that number. So it's 1 plus 6 plus 8, technically. Okay. So 1 plus 6 is 7. 7 plus 8, that's 15. I write down my unit. I carry my 10. So basically, this is like 15. Right? But I only write one value, the unit. And then I add again. So I don't just have 7 now. I have 7 plus 1, which is 8. 8 plus 4 is 12. I carry the 1. I write down the unit, carry the 10. 1 second. Okay. And finally, I have the 1 by my thousands column. So what I do is 8 plus 1, which is 9. Okay, let's do another example. 2059 plus 931. So 9 plus 1, that's 10. Okay, that's a 2-digit number. I write down my unit, carry the 10. Okay, it doesn't have to be a 10. Like I'm just saying the 10 value. Okay, it could be 20, it could be 25, it could be whatever, right? So it's never going to be, but I'm just saying. So 9 plus 1, that's 10. Then we have 5 plus 1, which is 6 plus 3. That gives us 9. Why are you doing this to me? Okay, nothing to carry over because that's a single value. Then 0 plus 9, that's 9. 2 plus 0, because there's no value there, that's just 2. So the final answer to 2059 plus 931, sorry, is 2990. Okay, so that's our revision of addition using columns done. Let's talk about subtraction. Okay, so subtraction again, thousands, hundreds, tens, units. Okay, so I'm going to start off with my units. I'm going to say top number minus bottom number, 3 minus 9. However, I cannot say 3 minus 9 because 3 is smaller than 9. So in that case, what I have to do, let's get rid of this. In that case, what I have to do is I actually have to borrow a tens from 7. So what I will do is I will change the 7, sorry, to a 6. Why do I do that? Because I borrowed a 10 value from it. Okay. And what did I do with that 10 value? I took it over and I gave it to 3 to now make it 13. Okay. So one more time, let's go through that again. So I'm going to start off with the units and say the top number minus the bottom number. However, my top number is smaller. So I cannot subtract 9 from 3. Okay. So because it's smaller, I have to actually borrow a 10 from the 7. So I cancel out the 7. I make it 6, 1 less than 7. And I give the 3 a 10 and it makes it 13. Now I can say 13 minus 9 and that gives me 4. Okay, so just keep in mind the difference. Here you add that 10 value like 1 plus 6. Here, it forms the tens number of the actual value. So you have a 10 and a unit, and that makes it now a bigger number than 9, for example. So it becomes 13. Then I'm going to move over to the next one, and I'm going to say top number minus bottom number. So in this case, I'm not going to say 7 minus 4. I'm going to say 6 minus 4. 6 minus 4, that is 2. Thereafter, I say 8 minus 9. 8 is smaller than 9, so I have to borrow 1 from 9. 9 becomes 8. This becomes 18. When I say 18 minus 9, I get 9, of course. 8 minus 1, 7. So the final answer for 9873 minus 1949 is equal to 7924. Let's do one more example. I have 9024 minus 4183. So initially I have 4 minus 3, which is 1. Now I have 2 minus 8, so I have to borrow from the next guy to make that 12, okay? However, this number is 0, so I can't really borrow anything from 0. It's impossible. 0 is nothing. So I need to borrow from this guy, but he's a 0. So then what I do is I borrow from the 9. So I borrow from the 9, I make the 9 8, okay? And steal that tens and put it for that number. So now the 0 is not just 0, it is now 10. Then again, remember, I need to borrow for those 2 still. Now I can borrow from him because he's no longer a 0, he is a 10. So I borrow the 10 from the 10 and it makes it 9. So from 0, it went to 10 because I borrowed the tens. Then I needed to borrow 1 for the 2. So it became 1 less, which is 9. And this guy could become 12. So 12 minus 8, that gives me 4. Then I can say 9 minus 1. So the most important thing is to make sure you have it lined up. Okay. 9 minus 1 is 8. Then I say 8 minus 4, which is 4. So therefore, the final value for 9024 minus 4183 is 4841. Okay, let's move on to multiplication. Okay, now with multiplication, right? Again, you want to do the same thing, okay, where you want to line up your units, line up your tens, line up your hundreds. So in this case, I first have a 3-digit number. So we're not starting small, right? Same with these, okay? These, they follow the same concept, but here we're not starting small. We're not doing 2-digit values, okay? For these lessons, should we be making notes? If you'd like to make notes, you may. The notes that I make for the notes that you guys see on screen, a PDF will be sent to the group, so you guys will have access to it. Okay. If you have a question, you may type it in the Q&A, or you may type it in the chat. If you want me to explain the minus sum again, just let me know one more time, because I was sorry I didn't see that message. Let me know one more time if you'd like me to re-explain it, and I go through it one more time. Okay, but in the meantime, we're going to, okay, I will do that. In the meantime, we're going to go through multiplication, and we'll just go back to the minus one more time. Okay, so multiplication, right? So what we want to do is we're gonna focus on the first number, okay? We're going to take all these values and multiply it initially by the 2 of the second number. Then secondly, we're going to multiply it by the 4 of the second number. Okay, so in the first column is where we're going to be dealing with multiplying it by the 2. So 1 times 2, 9 times 2, 7 times 2. Okay, so 1 times 2, I'm going to write it on this first column, then I'll have a second column, then I'll have my answer. So 1 times 2 is 2. 9 times 2 is 18. Okay, so now again, 18 is a two-digit number. I cannot write my two-digit number, geez. So what I can do is I write my unit and I carry my 10. Okay. Again, please keep in mind that I'm keeping everything beneath each other. I'm keeping my my structure consistent. So 1 times 2 is 2. 9 times 2, I'm writing it under the 9. 9 times 2 is 18. I write my unit, carry the 10. Then I'm going to say, not 17 times 2, I'm going to say 7 times 2, and I'm going to add the 1. 7 times 2 and add the 1. So 7 times 2 is 14. If I add that 1, I get 15. Now, the reason I write the entire 15 is because there's no fourth number to carry the 10 to. So now I can write it, the entire thing. So the 5 will be under the 7, and the 1 will be to the left of that. So everything is in line. Okay, it is important to keep that structure so that you can add it later on. Okay, so let's just go through that one more time quickly. So I'm going to work with the first number, multiply all three of these numbers by, so again, remember my focus was on the first number to multiply by each of the digits in the second number. So I'm going to say 1 times 2, which is 2. 9 times 2 is 18, two-digit number. So I write down my unit, carry my 10. 7 times 2, which is 14, plus that 1, which is 15. I don't have any other number to carry that 10 to, so I can simply write it down. Okay, let's move on to the next step. Now I'm going to work. So I've worked with the 2. So 1 times 2, 9 times 2, 7 times 2. Now I'm going to work with the 4. So basically 1 times 4, 9 times 4, 7 times 4. Okay. However, whenever you have an additional digit, meaning in the second number, so in this case, we're working with multiplying by a two-digit number, which is 42. In your second step, you will always add an additional 0. Okay. So for example, here where we have a 3-digit number multiplied by a 3-digit number. Okay. Initially, we'll do our calculations. We'll have a number here, a number there, a number there, and maybe a number there as well. Right. So that would have, let's just color code it so that we're able to identify it. So that would be for this number 3. If we're going to work with this number 4, we're going to put a 0 first and then do our calculations Okay. What about if we work with this 3? Right? When we move on to the third number, we're actually going to put 2 zeros and then do our calculations. Okay, so just keep that in mind. Let's move this along. So in this case, we have a two-digit number. So for the second digit, we have to add the additional 0. Then we can do our multiplication. So 1 times 4 is 4. 9 times 4 is 36. Okay, so that's a two-digit number. So I write down my unit. And remember, this one was for the previous number, so we can scratch that out now. I write down my unit and I carry my tens, 36. Okay, 9 times 4, 36. Write down the unit, carry the 10. Then I have 7 times 4. Now, 7 times 4 is 28. All right. And then I add the 3, I get 31. 791 times 42. Okay, I hope we're all on the same page. So let's just repeat this step one more time. So remember, I'm adding my 0 because of the second digit. Then I say 1 times 4. I say 9 times 4, 36. Write down the 6, carry the 3. Again, that 1 was for the previous number that we carried the 1 for. Please don't confuse it and add it again. Then I say 7 times 4, which is 28, plus 3, which is 31. Now, all I do is I've multiplied 791 by 2, and I've multiplied it by technically 40. So I can add these two. So in this case, if you had 3 columns, 3 rows, you'd add all 3. So now when I add them, remember we did addition. So units, tens, hundreds, thousands, 10,000s. We need to keep them. That's why we keep them in that order, so that when we're adding them, we do not mix it up. Okay. So 2 plus 0 is, of course, 17. No, it's 2. 8 plus 4 is 12. I write down the 2. I carry the 1. Okay, write down the unit, carry the 10. Then I have 1 plus 5, which is 6. 6 plus 6, 12 again. So I write down the 2, carry the 1. 1 plus 1 plus 1, which is now 3. I get 3. 0 plus 3 is equal to 3. Okay, so I have a question. Yes, the videos will be recorded. It will be on YouTube. Okay, and you'll have access to it. We will put the link for the playlist for all the lessons that we're going to have. It's going to be on the playlist and you will have access to it at any time. Okay, so I have another question is, why do we add the zeros? So the reason we add the zeros, it's not important for you to really understand, okay? It's more so important for you to understand when to add the zeros, okay? So let me go through that one more time. If we had to have multiplication by one number, 273 times 4. In this case, we'd have no zeros simply because we're dealing with one multiplication of a single number, just a unit. So it's say 3 times 4, which is 12, 7 times 4, which is 28, 29, 2 times 4, which is 8, 10. Okay, then there's no need to add that zero in the beginning, right? We simply just do that calculation. Okay, however, now because we have two digits, remember, I am saying 1 times 4. I am saying 9 times 4. I am saying 7 times 4. But in actuality, what it is 40, because this number is 40. Sorry. This number is 40. Remember, because, nope. Because this number is actually 40 plus 2. So if I say 1 times 2 and 9 times 2 and 7 times 2, that's fine because 2 is the unit. 2 is all the number has. But I am saying 1 times 4, 9 times 4, 7 times 4, not times 40. So because I'm saying just times 4 times 4 times 4, I add that extra 0 to compensate for the fact that it's actually 40. Okay, again, that understanding is not so important. However, when to do it is the most crucial thing. Okay. Cool. Okay. All right, let's move on. Let's do our let's do this example quickly. We'll try and speed through it. So I'm going to leave that there and I'm going to rewrite it. 282 times 3, 3, 4, 3. Right. Now I have 3 numbers by 3 numbers. So again, I'm going to work through it step by step. And I know that I'm going to have 3 rows because of these 3 digits here. So firstly, I'm going to work with, look, if you'd like in your notebook, right, when you're learning, when you're practicing, okay, it's not an examination. When you're at home doing your homework, there's no rules to what colors and pens and that you can use. So initially, if color coding, it helps you, you may use color pens, highlighters, whatever, right? Feel free to do it because it can help. So let's work with 3. Now I'm going to say 2 times 3, which is 6. 8 times 3, which is 24. So I write down my unit, carry my 10, 24. Then I have 2 times 3, which is 6. And I add 2, that gives me 8. Now I'm going to work with my second number, which is 4. So now in order to work with 4, it is the tens. So I'm going to add single 0. So remember, like units have no zeros, tens have 1 0, hundreds have 2 zeros. And that's exactly what we do in multiplication. For the 10 number, we add a 0. For the 100 number, we add 2 zeros. Okay, so now I'm going to add my 0 first. Then I'm going to say 2 times 4, which is 8. Then I'm going to say 8, so we can get rid of this. I'm going to say 8 times 4, which is 32. So I carry the 10, write down the unit. 2 times 4, which is 8. 8 plus 3 is 11. So remember, there's 2 additional values here now. Let's write them a bit further apart. Let's work with this guy, that 3. So with that 3, I need to add 2 zeros because that's actually the 100 value. It's like 300, not just 3. Okay, so it's 2 times 3, 8 times 3, 2 times 3 again. So 2 times 3 is 6. 8 times 3 is, you can get rid of that. 8 times 3 is 24. So I put the 2, carry the 2, sorry, put down the 4. 8 times 3 is 24. 2 times 3 is 6, plus that 2 that I carried is 8. Now what I can do is I can add all of these together. So I add these. Again, that's why it's important to keep everything in a row. All the numbers by 3 times all the numbers by 3. Yeah, so you're going to say all these numbers times 3, all these numbers times 4, all these numbers times 3 again, whatever the bottom values are. Okay, so now when I add them, I'm going to get 6 plus 0 plus 0 is, of course, 6. Right? 4 plus 8 plus 0, that is 12. 9 plus 2 is 11. So 8 and 1 is 9. Plus 2 is 11. Plus 6 is 17. I have 1 plus 1 plus 4, which is 6. And I have 1 plus 8, which is 9. So my final answer for 282 times 343 is equal to 96726. Okay, let's just quickly revise our subtraction. Let's do this question one more time. Okay, so first things first, we're going to say subtraction. So it's going to be top minus bottom, starting at my units. So I'm going to say 4 minus 3. So 4 minus 3 I can do, that's 1. Then I'm going to move over to my tens, and I'm going to say 2 minus 8. 2 minus 8 cannot work because 2 is a lot smaller than 8. So that's when I need to start borrowing. So I borrow from the next guy, my neighbor over here. However, my neighbor is 0, and he cannot give me anything. Therefore, this neighbor has to borrow from the even next door neighbor, okay, which is a 9. So therefore, it's possible to borrow from that number. So when you borrow from the number, it becomes 1 less, and you carry the tens value over. And it's not 1 plus 0. It's the whole thing combined forms a 2-digit number, which is 10. Now this guy is 10, and the 2 can borrow from it. So the 10, when you borrow from a 10, it becomes 9, 1 less. And then this guy becomes 12 because it borrowed that 10. Then I say 12 minus 8 is 4. 9 minus 1 is 8. 8 minus 4 is 4. And that's my final answer. Okay, let's move over to long division. Okay, just type in chat really quickly. How many of you are still doing long division? Or you can just tell me if many of your teachers have actually shifted over to just tell you guys to do short division. Just long or short, that's it. Long, 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 short, long, long. Okay, quite a few long. Okay, let's work through long. Okay, so when it comes to long, or when it comes to division, thank you, everybody, thank you. Okay, so when it comes to long division, I didn't say anything about long and short. Okay, doesn't really matter. Okay, because both work. Okay, and if you understand long, you should understand short. Okay, but yeah. So when it comes to division, okay, remember we are saying, how would we phrase this sum? Okay, we would say 4649 divided by 3. We would say 4649 divided by 3. We're not saying 3 divided by 4649. So this would be 4649 divided by 3. Alternatively, it could be written as 4649 over 3. Okay, how I like to remember it, just in case you're doing a problem sum and it's expressed in English or whatever it is, so that you understand what's going on, is that the top is, let's just say we have a certain amount of apples that we need to distribute amongst a certain amount of people. Okay, so the top number, so the top number is going to be the number of apples and the bottom number is going to be the number of people. So this is just to understand division and to understand its like the different notations of division. And again, if it's stated in a word sum, okay, you'd know how to approach it. So in this case, when we do this division, we are dividing 4,649 apples between 3 people. So you can imagine that each person is going to get quite a bit of apples. Okay. What else I wanted to say? Yes. Okay. So that's why when it comes to dividing by 0, for example, let's just say we have 10 apples and we divide by 0. Okay, let's start with the other one, right? Let's just say we have 0 apples and we divide it by 15 people. Okay. In this case, how many apples is, okay, so, and then your final answer, sorry, this is equal to number of apples per person. Okay, so the final answer of that division is how many apples each person is going to get. So when we say 0 divided by 15, each person, because there's 0 apples, each person is going to get 0 apples. Okay, makes sense. So this answer, 0 divided by anything is always 0. However, if we had 27 apples divided amongst 0 people, how many apples does each person get? That doesn't make sense because, okay, I'll get to your question in a bit. Okay. That doesn't make sense because you can't give an answer to how many apples each person is going to get because there's no people, right? 0 people. So how can you say you can't give a value to how many apples each person is going to get because there's no people. So that's why always when you divide by 0, it's not, that's exactly why, but I'm just trying to, it's just a basic, more friendly explanation of that. Okay, but nevertheless, let's try to, I'm going to get to the questions afterwards. Let's just focus on finishing this log division. Just going to do one example, then we'll have to end because time is almost up. So when we're doing long division, we're going to ask ourselves, we're going to work with this number. We're going to say, how many times does this number go into each of these values, right? So we're going to start off with the 4. Okay. When we work with the 4, right, 3 can go into 4 perfectly fine. We ask ourselves, how many times does 3 go into 4? 3 goes into 4 one time. Okay, I will get you guys questions. Please don't think that I won't. I'm just going to finish this and then I'll answer them afterwards. 3 goes into 4 one time, so we're going to write a 1 there. Then with long division, what we do is we take this 1 multiplied by the 3 and we write it beneath the 4. So 1 times 3 is 3. Then we create a subtraction where we're going to say 4 minus 3. That's actually going to give us the remainder. So 3 goes into 4 once. And then when we say 4 minus 3, remainder 1. For the person that said they got disconnected, because time is almost up, what you can do is you can rewatch this later on. Okay. So 1 times 3 is 3. We say 4 minus 3, we get 1. Thereafter, what we always do is we bring this number down. So when I bring that number down, I get a value of 16. Then I ask myself, how many times does 3, okay, go into 16? So 3 can go into 16, 3, 6, 9, 12, 15. So 5 times. And to calculate the remainder, I say 5 times 3 and write it beneath 16. 5 times 3 is 15. I do subtraction and I'm left with 1. Okay, again, 3 cannot go into 1. So what I need to do is I need to bring this guy down, the 4. When I bring the 4 down, it becomes 14. Thereafter, now I can say, how many times does 3 go into 14? 3 goes into 14 4 times, because 3, 6, 9, 12, 15. 15 is bigger than 14, so the largest amount of times is 4. I say 4 times 3, which is 12. I subtract the 2. Obviously, that 1 minus 1 gives us 0. The 4 minus 2 gives me 2. 3 cannot go into 2. That's why I bring the 9 down. When I bring the 9 down, I have 29. 3 can definitely go into 29. How many times can 3 go into 29? Geez, basic maths, 9 times, I believe, because it's 7. So 27, sorry. So 9 times. When I say 9 times 3, I get 27. Finally, with this remainder of 2, that's obviously 0. All right. Now I have nothing to bring down. Okay. That just means the number is done. Okay. So 3 cannot go into 2, but your final remainder, you always put at the end as an actual remainder. So you'll say R2, meaning remainder 2. So 3 goes into 4649, 1,549 times the remainder 2. Okay. So yes, okay, we'll end it there with regards to this topic. You wrote a 9 instead of an 8. Where exactly? Okay. Yeah, we'll do in our next lesson, we'll continue with this. And actually, after this, we have to do HC, highest common factor, lowest common multiple, and as well as like rate ratio. Those are following. Okay. What I will do is I will try in the week to release a timetable for you guys so that you guys know what topics are upcoming for that person who asked for integers. You'll get a better idea. If you are like writing in this week, unfortunately, because we started a bit late, what we're going to do is we're going to try and catch up as many topics and at least prepare for your final exam at the end of term 1. Okay, so I'll try my best in this week to release a timetable for the rest of the term so that you guys know which topics we are covering and you can plan accordingly your studying. Okay, but yeah, we'll go through short division in the next lesson as well. Okay, thank you guys so much, and I will see you guys in the next lesson. Amen.